This is Duke University.
So last but not least, we have Alexandra Oprea, who is a fifth-year PhD candidate in political science with a focus in political theory and political economy. Her primary training as a teacher and a researcher has been empirical and normative political science with a focus on education, politics, and policy. The questions she pursues are primarily normative, concerning the proper relationship between liberty, representative government, and public education. To answer these questions, she uses a historical approach, focusing on how key figures in the 17th through the 19th century history of liberal political thought justified their educational proposals in light of their other commitments to justice, rights, and limited government. In addition to her scholarly work, she has also consistently pursued teaching opportunities and pedagogical training as an integral component for thinking about education at both the K-12 and university levels. She also has an enduring interest in the role of political humor in shaping political culture and appreciates your emails with jokes, puns, and gags in different languages and cultures.
Thank you very much. It is very strange to be at a Wednesday at the center and not have political cartoons behind me. So those of you who know me, today I'm going to talk about something serious. In fact, I would say the topic of the summer school that I attended in Vienna was exceedingly serious in 2015. Our concern was the computational turn, both in the natural and in the social sciences. The team that was there involved a number of philosophers of science and actual scientists from a variety of disciplines. And our coordinators were Paul Humphreys, Rainier Hegzelman, and Margaret Morrison, three empirical and normative political scientists and philosophers who guided us through a series of very interesting questions. I put on the board many of the topics that we talked about and engaged throughout the different sessions. But what I'm going to do in these short 5 minutes is pick three of these topics and just give you an idea for the kinds of questions we explored. So one of the first topics that we explored was the role of simulation in science and the limits of knowledge, the limits of human knowledge. What I have behind me is a picture of the Large Hadron Collider. Many of you may recognize this. And the Large Hadron Collider is used right now to perform very cutting-edge research in physics and particle physics. And one of the interesting things about this form of technology is that simulation pervades the role of the researcher. We're used to thinking of science as a person interacting with the material world, and the material world kind of pushing back. So you drop a ball or a feather, you see how fast it goes, Newtonian sort of science. But in the Large Hadron Collider, not only are we simulating the particles when we're accelerating them at very fast speed, but we don't know if we got the results that we expected to see. It's not like the results are visible to the human eye. So then we simulate the results as well. And then we test whether the simulations of what we are doing to the particles match to some statistical degree the simulations of the results that we would expect to find if we were right. So material world doesn't even enter into the picture anymore. But not only that, human beings barely enter into the picture. To get a 5 sigma result of the kind that you would need to talk about the boson, the latest discovery of the particle, you've got computers testing the results of multiple teams of scientists, none of which individually understand or know the code of each of these procedures. So we're reaching a point where human beings are involved in the process but no longer have the overarching mind controlling the process. And that can be very uncomfortable for scientists used to the old way of thinking about their control over environments. And so we talked a lot about how we might harness human knowledge even when individual human minds don't have the entire capacity to understand the result. Now, another topic that was very dear to my heart was agent-based modeling. And in a previous life, I was a political scientist, not a political theorist. And Rainier Hegzelman had some of the most beautiful models and ways of visualizing political activity that I have ever seen. This is a 3D model of trying to think through how people are influenced in their voting behavior. And he also had 4D and 5D models, to the point that he was using sound to mark transitions, to the point that he was using video and sound to show us all these different dimensions. And I wish I had more video, because these are beautiful, beautiful visualizations. But the point of agent-based modeling is, instead of trying to predict how human beings would, instead of trying to observe how human beings have behaved, these are simulations in which you put together 100 voters, give them some parameters, and then see what happens to society. And this is one way of studying consensus or polarization, studying how very small butterfly wing-like changes in the beginning of the setup will influence the results dramatically. And so he can simulate evolution over time, human societies, he can simulate politics, he can simulate how radicalization works when you have one figure who pulls everyone towards them. So these are some of the issues that agent-based modeling helps us to resolve. Now, a lot of people at the Vienna Summer School were either scientists or philosophers of science. And so one of the big questions they had when I showed up was, what do we do with this education person? They didn't really think that there was going to be a discussion about education, since they're talking about these lofty questions that the most sophisticated minds in the world can barely grasp and get their minds around. But since I was there, I considered it my mission to get them to think about scientific education at the K through 12 level, particularly since what we're dealing with, as Sam has very clearly articulated, is a world where our problems are very sophisticated. We're asking voters to give their input on macroeconomic policy. We're asking voters to give their input on war and foreign policy of one of the largest countries and the largest militaries in the world. And we're asking them to give their input on climate change and policies that affect the entire environment. And given that, we cannot possibly rely on the average information that the average citizen has, given that our training is woefully obsolete. So issues of statistics, issues of how to interpret large-scale data, issues of how to deal with uncertainty and how to deal with the fact that even though we don't know everything, we need to make judgments about politics. These are some of the issues that I forced them to engage, and I got a lot out of it, because it turns out they were very happy to, even if it wasn't on their original agenda. So, in conclusion, I want to thank Malachi and to thank everyone again for the opportunity to participate in the summer school, and I'm happy to talk more about any of these issues. So thank you.